Talk Space. This is the chance we have to talk to Tim Peake about what's going on in space. I'm Jeremy Curtis from the UK Space Agency. Hi, Tim.
Hello, good morning, Jeremy, and good morning to everybody who's watching us this morning. This is going to be a great episode, one of my favorites, because we're talking about my favorite planet, Mars. That's favorite planet other than this one that we're all on right now, of course. Earth is by far the most beautiful, but it's going to be a great discussion, lots of interesting facts about Mars and finding out why we're going there and what we're planning on doing in the future.
Before we do that, I think it was about 4 years ago you got back from the International Space Station. And one of the things that I think would be useful to remind everybody is they can see it for themselves. Tim, I think this is a pretty good week for seeing it, isn't it?
It is actually, yes, we've got a pretty good week, although you're going to have to give up a bit of your sleep because it's either going to be early morning or you're going to have to stay up a little bit later at night. But Wednesday night's a pretty good pass. It's about 11:15 at night. So if you're allowed to stay up till then, you'll get a great pass to the ISS on Wednesday night, weather permitting, of course.
So you can have a look and find out where to look and when in the future, as well as this week, if you go to either Heavens Above or Spot the Station. That's the NASA version. So have a look for yourself. It's well worth a sight because it's really bright when you can see it. Anyway, this week we're talking about Mars, and with us we've got two experts. First of all, from Airbus, we have an engineer, Yvonne Pickering, and from Open University, we've got Manish Patel, who's a lecturer in planetary sciences. Hi, Yvonne.
Hi.
Hi, Manish.
Hello.
Nice to see you.
Hi, everyone. Hi, Manish. Good to see you, and thank you for joining us this morning.
It's a pleasure.
And online, we've got some experts as well to help answering your questions. So I can see there's already lots of questions coming in. So keep them coming, and our experts will do our best to answer them for you. And we'll try and pick up some of them as we go along in the discussion. But first, Tim, why are we so keen to get to Mars in the first place?
Yeah, why Mars? Gosh, I mean, Mars has held human fascination for thousands and thousands of years, really looking up into the skies and seeing the red planet. And then as we've gradually understood more and more about it, but I think it captures our fascination and imagination because it's a very similar planet to Earth, one of the rocky planets. Is not that far from the sun, and actually amazingly 3.8 billion years ago it was very similar to Earth. The atmosphere on Mars would have been much thicker, denser, and that means it would have been a warmer planet. And some amazing facts for you. We've already found that there are 21 cubic kilometers of ice on Mars. Now, if all of that melted, that would cover the entire planet up to a depth of 35 meters in water. So once Mars was potentially a stunning planet of a third of it covered in ocean. So it's absolutely fascinating. We know that where there's water, there's the chance of life. And we're going to talk a lot more about that in this episode. But, Mars is a fascinating planet and potentially harbors another source of life within the universe.
And Manish, is it the same for you? Do you have other reasons why you need to get to Mars?
Yeah, it's pretty much the same. I fully agree with Tim on all those points. It's the world on our doorstep, and it's cosmically, it's right there waiting for us to explore it. And to hear someone like Tim say he wants to, we should go there, we should explore it. That's just fantastic. And for me, it really is that fact that the Mars you see and know today is not the Mars that's been there for eternity. As Tim said, it used to be this totally different planet. We go there now and we can see from orbit these huge rivers, massive carvings of water into the surface that we see here on Earth. And that tells us there was water there a long time ago. It was a very different environment. And the red Mars we know of today was actually a blue Mars in history. And it's this blue Mars which is really fascinating because all that water, all that atmosphere means that it really was the conditions for life potentially way back in the past. So questions of where did that atmosphere go? Where did that water go? And if there was life, can we maybe try and find some signs of it now?
And we've got the first question to ask you from Tilly, who's 6, who asks if the reason that Mars is red is because there used to be water and the water has turned it to rust, which I think is quite a good question, don't you?
That is a fantastic question. It's a very good question, Tilly. Essentially, you are right. The reason Mars is red is because there's lots of iron there at the surface. So the rocks at the surface are made of iron. as you said, when iron gets wet, it rusts, as you know. On Mars, we don't know what quite has caused it, so we suspect it is linked to the water, but it's actually the oxygen that causes the rust. So in the air, we have oxygen here, and if you leave your tools out in the garden or something, they will rust, even if it doesn't rain. We don't know whether on Mars, was it all this water in the past, which came down in a massive rainfall that rusted everything very quickly, or was it a gradual rusting over billions of years that slowly turned Mars into the red planet we see today? But essentially, it comes back eventually to the oxygen in the air, which most likely comes from that water.
Brilliant. Right. So there's a lot of reasons for going there. But there have been so many missions in the past, an awful lot of them have failed. Tim, why is it so difficult to get to Mars?
Yes, I mean, getting into space anyway is hard, and we know that already. We see rocket launches failing today. And to get to Mars is even harder because it's so much further away. Your launch window is fairly short, just a couple of weeks, and it only happens once every 2 years because Mars is further away from the sun than Earth, which means it's orbiting more slowly. So Earth orbits once around the sun, but a Martian year is 2 years around the sun, 2 of Earth years. So we have this small window in which we have to launch to Mars. Of course, it's so far away that we've got a communications delay. So all of the re-entry, all of the landing of a spacecraft on Mars has to be done autonomously without any sort of input from us on Earth. In fact, we had this terrifying 8-minute wait before we even know if the spacecraft landed on Mars or not. And we spoke about the Martian atmosphere billions of years ago being much more like Earth. But today it's very, very thin. A lot of that atmosphere has escaped off into space. And the Martian atmosphere is only 1% of what it is here on Earth. So to put that into context, that's like going up to 35 kilometers high here on planet Earth. That's about the same pressure as you've got on Mars. So that makes it hard to slow a spacecraft down. When I came back to Earth in the Soyuz capsule, we used the lovely thick atmosphere of Earth as a massive air brake with a heat shield. And that really slowed us down to just 1 times the speed of sound, which is slow enough for a good parachute to open. And then the parachute's got lovely thick air to slow you down. And that's all we needed really to land. But in Mars, such a thin atmosphere, you come screaming into this atmosphere. There's no air to slow you down. So the parachutes don't work very well. The heat shield doesn't work as efficiently. And you need something else, something like airbags, or as we've used in some previous rovers, actually sky cranes with rocket propulsion to hover over the surface and then lower down a rover. These kind of things are techniques we need. So Yvonne and Manish, that's their job. It's a tough one. They'll know better than I do about how hard it is to get to Mars and to land on Mars.
Brilliant. So that's how difficult it is. Tell us about the mission you're working on, Yvonne. What mission is it and how are you getting there?
So the mission I'm working on is the ExoMars one, which is the rover that is now due to launch in summer 2022. Unfortunately, it was originally planned for 2020, but there were just too many tests to finalize to authorize it to launch. And so the experts have decided that it's better to delay and go for the 2022. So this is a rover that's going to look for signs of life, and it's going to drill into the surface to test some samples to see if we can detect evidence that there was once life on Mars.
The pictures we can see at the moment, where is that?
Oh, so yeah, the picture that's on screen, this is the rover being assembled in our ultra clean facility that's at the Stevenage Airbus site. So because we're looking for signs of life, we don't want to take any life with us because we might get a positive that's actually just matter that we've taken with us. So we call this our bio-clean facility, and it takes the people inside a long time to get ready just to go inside in order to maintain the clean facility.
Brilliant. So it's probably one of the cleanest places you could be in this day and age, people trying to isolate and wear masks and so on. I imagine it's probably a pretty safe environment for anybody trying to avoid COVID at the moment as well, isn't it?
It is, yeah. It's actually, in real life, you have about 200 spores on about 1/8 of a pinhead In that facility, we're working to an accuracy more like 200 spores per square meter.
Wow.
So spores are sort of dust particles and things that we have sort of around us every day, and that's how clean that facility is.
Amazing. Now we've got another question. I'd like to go back to what it's going to be like when you get there. So Tim, we've got a question from Lindsay's 5-year-old. We don't have his name, I'm afraid. Wants to know what it would be like to walk on Mars. So when this rover finally arrives, I think it'd be useful to have a feel for what Mars is actually like.
Yes, well, that's a great question. And actually, you know, if you're 5 years old, then you're in the right age bracket for perhaps being the first human to walk on Mars. So what's it going to be like? Well, Mars is a smaller planet than Earth. It's about a quarter of the size of Earth, which means it doesn't have as much mass, which means it doesn't have as much gravity. The force of gravity is much weaker. It's about 38% of here on Earth. So actually, you would feel a lot lighter. Not as light as you would on the moon. On the moon, we've seen photos and videos of the astronauts who are doing the bounding, the sort of jumping along the moon. Not quite that light, but you do certainly feel a lot lighter. I actually got to experience it in the back of an aircraft on the Vomit Comet, as we call it, the parabolic flights. And we had a few parabolas where they gave us the moon's gravity, and they had a few parabolas where they gave us Mars gravity. So we were able to walk around in the back of this aircraft feeling what it was going to be like. But of course, we can't survive in the Martian atmosphere. It's mostly carbon dioxide. There's no oxygen there to breathe, and the pressure is dangerously low. I've already mentioned it's very thin atmosphere, so we'd need a spacesuit in order to survive on Mars.
And there's a lot of dust. Manish, can you tell us a bit about the dust on Mars?
Yeah, dust. There's dust everywhere on Mars. Mars is interesting because there's no water at the moment on the surface, so everything can go crazy on Mars. In the video now, you can see the video is actually on Earth. So we're driving through a thing called a dust devil in the US desert there, which is a swirling tornado of dust. So they're quite common on Earth. You don't really get them that much in the UK, but in desert regions you get them a lot. So you get these tornadoes of dust chucking all this dust high up into the air, and it stays there for a long, long time. Mars is really fascinating because everything on Mars gets bigger. So the same kind of dust devils on Mars. The one you're seeing in the video is Earth, and that's about 500 meters tall, maybe. On Mars, they go big, they supersize. They go to 12 kilometers high, the one that you're seeing an image of here. So they really turn into these monster dust storms. And dust is actually something that could engulf a whole planet on Mars. So imagine a dusty storm here on Earth. Imagine that engulfing the entire planet. That's what happens on Mars. These things go out of control. And just last year, or the year before, we had a global dust storm on Mars. So dust is a real interesting thing in the atmosphere of Mars. It drives everything.
So Tim's talked a little bit about how we're going to land when we get there with parachutes and things. But what are we going to do on the surface? What actually happens when the mission arrives at Mars? So
the aim is to get there and drive around with the rover that is being sent to Mars now, and go investigate the surface of Mars. So you can see here a really nice image rotating around the rover that we're going to be sending. It's equipped with all manner of scientific equipment to analyze and understand the rocks it goes up to, and really importantly, it's got this big drill on it. And this is the first time we are ever going to drill deep into the surface of Mars. I say deep, I mean at the 1 meter, 2 meter level. You can see the drill box there at the front of the rover. That will come out and it will drill down. And importantly, it will take something from below the surface, bring it up and analyze it. Why is that important? Well, everything below the surface is protected. As Tim said, it's a very harsh environment at the surface of Mars. Not conducive to life at the surface, we know that. There's radiation, there's low pressure, it's really cold. So we think the best place to find life, or at least remnants of life still surviving, is below the surface. And that's what this rover is going to do that no rover has ever done before.
Now, Tim, you announced the name for this rover last year. Can you tell us who it's named after and why?
Yes, yeah, Manish alluded to it there, the Rosa, Rosalind Franklin. So I had the great honor of being able to announce the name for the ExoMars rover. And Rosalind Franklin was a great British scientist, a chemist and a crystallographer who was responsible for helping us to understand the molecular structure of DNA and RNA. So really the building blocks of life as we know it here on Earth. So it seemed very appropriate that somebody who is so involved and so crucial to our knowledge of life should be remembered in terms of a rover who's searching for life on Mars.
So let's talk a bit to Yvonne then about how the rover actually works. So when it gets to the surface, how does it move? How's it powered? Does it work when it's dark or dusty and so on? How does all that play out?
So the rover is actually entirely solar powered. You can see on the top there were the big solar panels that are its only source of power. So theoretically it could work when it's dark, but we can't really gain enough enough energy really to sustain it during the night. And actually it's more important that the rover keeps itself warm. So sort of an average night on Mars, it might go down to minus 70 degrees, which is pretty cold.
Yeah.
And we've got to make sure that all of the various components of the rover will still be working in the morning so we continue the driving. So as you can see, the video that's on the screen currently is the rover climbing over a rock. So we're probably going to have to do a lot of this on Mars, and the rover can climb over anything about the height of its wheel. And the way that it does it is that it takes images of the ground in front of it up to about maybe 10 meters. And it has to imagine putting a model of itself at each point, and it can decide whether the rover would be safe to be there. If there's too many rocks or the slope's too steep or something, then that makes it not safe for the rover. And doing this, it can then build up like a safety map of where it can and can't go, and uses this to drive.
And so it's basically trying to anticipate the future, I suppose, isn't it? It's doing what humans do, trying to predict what happens. So what's your role in it?
So I'm part of the team that actually they design the algorithms of how this rover establishes sort of the safe places it can go, and then actually drives it and makes sure that the rover is sticking to the path that it is assigned for itself. So yeah, this is a very complicated set of algorithms that the team has spent a long time designing. And it sort of tracks the ground as it's driving, and it's always constantly making sure that the rover is safe and where it thinks it is.
And you can see that it can cope with soft sand. I think the first video is of it coming down the slope. This one here is when it's getting off the lander, isn't it, as it's deployed. And then we can see it coping with different terrains. We've got a question here from 9-year-old Kieran, who wants to know if you could send a rover to the polar ice caps. What do you think of that idea?
I think that's a really interesting idea, and actually the polar ice caps might be quite an interesting place to explore. I think there have been previous missions that have looked into this, but obviously we've decided for this particular mission not to, but who knows what will happen in the future.
So Tim, you were involved in testing out some of the technology for Mars exploration when you were on the ISS. Do you want to tell us a little bit about what that involved?
Yes, well, I mean, something we're anticipating is astronauts more and more having to control rovers and robotic exploration vehicles from spacecraft, whether that's in orbit around the moon or in the future en route to Mars or in orbit on Mars. So we're doing a lot of work in terms of sort of human robotic interface, how we can actually control the rovers. Things like haptic feedback. So as we're controlling a rover, we actually get to feel the forces that rover is experiencing on our hand controllers, whether it's going up over hills, over rubble, and that gives us even more situational awareness. And also a communication system that's much more robust than just one single link from the controller to the rover. We're looking at a kind of internet type system out in space, and that makes it a very robust communication system to the rover. So we tried all these systems out, and those experiments are ongoing. And I got the opportunity to drive a rover. It was a prototype of the ExoMars to the Rosa rover from the International Space Station, driving that around the Mars yard in Stevenage, which was pretty cool.
Go on.
Tim, did you get any sort of any suggestions that would be helpful for us designing a rover in the future?
Oh, absolutely, yeah. And in fact, a lot of the work I did on when I was a test pilot on helicopters, looking at sights and sensors and how we use those and how we get the situational awareness. You were talking, Yvonne, there about the rover making a map for itself. And it's all about that. It's about creating this image so that we can control the rovers and get as much information as possible. So there was loads of good feedback there about how we can make this easier for humans to control rovers and get that information back.
So the point about your experiment was in order to show what would happen when we have humans in orbit around Mars controlling a robot on the surface without the long feedback, the long time delay. But, wouldn't it be easy just to send up for humans, real astronauts, to the surface, Tim?
Absolutely. And as somebody who's passionate about human spaceflight, that's exactly what we're aiming to do. But the other great thing about rovers, of course, is that they help to de-risk missions for humans to follow on. They help to scout out where are the best landing sites, where are the best chances of finding life, where are the best chances of astronauts being able to build habitation modules. We've heard about this horrendous conditions on Mars, sometimes with dust storms and the thermal conditions, the temperatures. And so we need to be able to live and work there. So rovers can go there first of all and scout this out and build all this information up. So by the time we send humans there, we have a really robust mission. We know where we're going, why we're going there, and what to expect when we get there. And of course, it's cheaper to send rovers ahead of time to do this than it is sending humans there and then finding out that we got it wrong.
So Manish, what part of the mission are you involved in then? I think you're involved in one of the instruments, aren't you?
Yes, I am. I just want to go back to just for a second and say, Kieran, 9 years old, you are spot on, because that is exactly what we need to do. We need to go back to Mars. We need to go to the poles, and we are trying. People like me are trying to convince the space agencies to go there. So we need more Kierans. I'm more like so yes, I'm involved in the PanCam instrument on the rover, which is the eyes of the rover. So two cameras, actually three cameras at the top of the mast, and it surveys the scene, and it tries to understand the environment that the rover is in and how to get to the interesting places we want to go to look at, analyze.
And where do you want it to dig?
So this is a big choice. We spent years debating where we should land on Mars, and we've chosen an area which is what we think an old lake bed type landing site. So you don't want to go to Mars and then land on a nice, pristine volcanic basalt, because there's not much chance of finding life there. So going somewhere where we think there was water in the ancient past that's kind of settled down and maybe brought some gas down with it into the rocks and sedimented out like that. That's the kind of place we want to go to and look for and dig. So that we'll use the eyes of the rover to figure out where to go, and then we'll go there and investigate.
And so, Yvonne, what are you going to do with the samples when you've got them? What happens next?
So we like I said, we drill down, we take the samples, we go into the rocks, take the samples. We have a series of fantastic instruments. We pack huge laboratories that you normally find in universities and research organizations, etc. We put them into boxes this big and we analyze them. So one of the things we do is take samples, burn them essentially, break them up into bits, and try and understand what all those little bits are in order to find out what something's made of. So we're trying to find the ingredients essentially of what we're analysing.
So I guess you're going to find it pretty difficult to find out whether you've actually got life there. I mean, how do you do that?
It's fantastically tricky to identify life, it turns out. If it pops up in the camera in waves, it's nice and easy. Trying to understand it at the component level, when you're given a piece of rock, trying to identify whether there's life in there, unambiguous. So to be sure that it is life and not anything else, it's actually pretty difficult.
Mm-hmm.
So we try to look for things that are unusual, out of balance, and that's really the best indicator of life. As living things, we tend to disrupt the environment we are in, so we throw things out of balance. And that's what we really look for when we take these things apart.
So with this mission, we're going to be doing all the tests on board using Yvonne's rover as a laboratory, aren't we? Tim, what happens next after ExoMars?
Yes, so I mean, Manish is just describing there what ExoMars is going to do. Fascinating to try and detect signs of life and then transmit that information back to Earth. But the next step, of course, is not to transmit the information, but to actually bring back pieces of Mars itself so that we can analyze it in our own laboratories and do much more stringent testing and much more in-depth testing. So how do you bring a sample back from Mars? Well, it's a very long, convoluted process. And the United States NASA are launching a rover this year called Perseverance, which is going to be the first stage in this Mars sample return system. And so Perseverance will have a drill, much like ExoMars, a little bit like ExoMars, and actually even has a helicopter on it. They're going to fly a drone in the Martian atmosphere, which is going to be fascinating.
Wow.
The first drone to fly, somewhere other than planet Earth. But essentially what they're doing is dropping off samples along the way. And dropping off samples with a view that another rover, which the European Space Agency are involved in, Mars Sample Return Rover, will come along and pick up those samples and then take them to a Mars Ascent vehicle, which will go and rendezvous with another spacecraft that's in Mars orbit, but will then bring back those samples to Earth. So this is a really ambitious program that's going to be going on over the next 10 to 15 years, maybe, in terms of retrieving these samples that are going to be taken next year. So it's going to be absolutely fascinating to follow.
So at home, you can look out for the launch sometime on the 30th of July or soon afterwards from the US for Perseverance. But Yvonne, what's the UK involvement in all this? I believe Airbus has got a big part of the this whole set of missions.
Yeah, so currently Airbus, for the Mars Sample Fetch rover, which is the rover that's going to go and collect up all these samples and hopefully bring them home. So Airbus is going to be building a prototype rover, or a breadboard, as it's sometimes called in engineering, that's just going to demonstrate the capability. And from then we'll move on to the next stages of the project.
Brilliant. So perhaps we can have Manish back on. So Manish, can you tell us what's going to happen to the samples when they get back to the Earth?
So this goes back to the days of when we brought pieces of the moon back to Earth. It's just literally out of this world stuff. This is the most precious stuff that is possible on the planet. But at the same time, we have to be very careful. So we're bringing pieces of Mars back, and that's a piece of another planet that's grown in, that's come about in an entirely different system. So we have to be careful. We've learned lessons about contamination, about bringing things into a new area. We're bringing something very new to the Earth, so we need to be very careful with these rocks. That means putting them in a very secure facility. So we would essentially be putting them under their own lockdown, very apt for now, but we put them in somewhere safe, and we analyze them, and we check them to make sure there's nothing harmful in there, but also very importantly to make sure we don't contaminate the samples. So if we're looking for life in pieces of rock from Mars, we've got to make sure we don't contaminate it with our own kind of life going in there. So they'll come back to Earth, they'll be put in a very, very safe place, and it's going to be scientists, it's going to be people like you guys at home who eventually will grow up, become scientists, and analyze these rocks from Mars. So you guys are at a very special time. This is a fantastic time to be a student, to have that kind of opportunity coming up for you in the near future.
That's a great plug for the fact that we do need more people. Yvonne, what's the most exciting thing about your job? Why should other people want to come and work in the same sort of field as you?
Oh, I think my job's amazing. Just to be part of the team that gets on a daily basis to be testing the rover and knowing that like a little bit of what you've done is actually going to another planet. I couldn't think of a better job, really. And
for you, Manish?
Yeah, absolutely. I've got to say, it's not a job. Someone pays me money to do what I love, and it's just fantastic. It's the idea of exploring the solar system with something you make and send out. It blows me away every day.
And if you look back and think of a message you would have given to your younger self, is there something you'd have done differently, maybe university or school?
I think I would have still followed the path I've done. My parents were fantastically supportive. They let me go the direction I wanted to. I think the thing I probably would have benefited from that I see now, I didn't see then, was languages. Understanding, being able to talk and cross barriers of communication and language. You don't work in isolation in science. You work internationally. You work with people across the world. It's fantastic. So I think if there was one thing I could have done more of, it would have been languages. That's for sure.
Tim, do you feel the same about languages, given the international nature of the crews of the ISS?
Absolutely. I mean, languages are so important. I really struggled actually to learn Russian at the grand old age of 37, but it was vital to working with the Russians, flying with the Russians. And of course, in the European Space Agency, my colleagues are German, Italian, French, Spanish. So languages are very important. And it's really enriching to learn about other people's culture as well. The great thing is that the more we're doing, the more ambitious our space programs are becoming. They're actually becoming more inclusive. We're having to work together with other international partners in order to do them. So international collaboration is the way ahead.
And Yvonne, you're working in, well, basically computing now. Are there any messages you would have given yourself about how things could have been different earlier on?
Actually, funny talking about languages, I'd say probably the same thing, except I'm talking about coding languages. I at university didn't really think that coding was maybe that important. I went for some sort of, I studied stars or things instead. But actually, I really wish I had taken a few more coding modules and sort of got to know a few different languages, because that really is so fundamental in so many different jobs in engineering now.
Brilliant. We've got one last question I'm going to try and fit in here from Ruby Jane. She's 12 years old. She says she's from Myanmar. She says she wants to be an astronaut or go to Mars. What can I prepare to be an astronaut? Tim?
What to prepare for, Ruby? Well, I mean, languages and culture and experience of other countries, as we've just heard there, is a great thing. As Yvonne was saying, things like coding, technology, engineering, these are becoming everyday parts of our lives. And in terms of what an astronaut does today and will do in the future, it's all becoming based around technology and engineering, having an understanding of things like, artificial intelligence and computing, which you all have the opportunity to study at school, which, I didn't have the opportunity so much. It wasn't really around when I was going through school. So really embrace those opportunities. There'll be so many people giving you guidance and advice, and listen to people, but follow, what you're passionate about. Follow that route, because that's your best route to happiness and to success. Essentially, astronauts come from all different backgrounds, but we are all passionate about spaceflight, and most of us have some sort of background in science or flying or engineering or technology.
Well, I'm afraid that pretty much runs out of our time now. So if you'd like to get involved at home, there's lots of things you could be doing. If you're interested in ExoMars, we've got activities at the Space Education Office, which link to Mars exploration and to ExoMars in particular. So there's links below this screen if you want to follow those up. Go to our website where we've got education resources you can use at home. So do have a look at those. Well, this was the last in our series of Tim Talks. So, Tim, what are you going to be doing for the rest of the summer?
Yes, the rest of the summer, I'm actually writing an autobiography, so I've got to knuckle down and get some work done for the next few weeks, which I'm actually looking forward to and enjoying. But yeah, so thank you everybody who's been listening to these Tim Talk sessions. I've thoroughly enjoyed them. I hope you have. Thank you, Jeremy, and the UK Space Agency for hosting them and putting them together, and for all the people like Manish and Yvonne for contributing all of their knowledge and experience and making the sessions so interesting. Thank you very much.
And if you fancy sending us any feedback through Twitter or whatever at home, then let us know what you thought of it. If there's enough positive ones, I'll try and bend Tim's arm, and we might try doing some more sometime. But if we do, we'll tell you about it through Twitter. So sign up to our Twitter feed if you're interested in that. And if you missed any episodes, they're all available to watch still on YouTube, so you don't have to miss anything. So thank you very much, everybody at home, for watching. And thank you very much, Yvonne and Manish, and most of all, Tim. Thank you so much for your time. We could have talked to you for hours longer, but you have other commitments, and so do we. So thank you very much for your time, Tim. It's been fascinating. I've thoroughly enjoyed it. And have a great summer, everybody.
Bye, everybody. Yeah.